So hi everybody. We'll go over the introduction about who I am. I am the CEO of HPQ, but what's really interesting is we have an interesting story that has been developing over the last 10 years, and I believe in the next 12 months to 24 months, multiple of our projects are going to reach the maturity stage. Typical cautionary disclosure. For those interested, this presentation is now available on our website and can be downloaded. So what are we really? Well, we're developing advanced material technology ready for a sustainable future, in a big word. We're working on three operating segments. One of them is silicon battery material. The other one is fume silica, and the third one is autonomous hydrogen production. We've partnered with top tiers engineers, technical people, people ready to move the technology in advance and to get things going. So we're partnered with Novasion, which is a French deep tech startup, which we're also shareholders, and Pyrogenesis, which is a plasma expert. And we're going from R&D to commercialization. For the last 10 years, we've really been working on silicon-based engineering. The guys at Novasion has been doing a lot of work on critical hydrogen processes. We've reached a point now where we've made some batteries that are certified, which are ready for commercial stage. The concept is, and I'll explain it a bit better, but we do silicone material that makes battery better. And we're government backed. We've demonstrated we've won a $3 million grant to build a dedicated facility to manufacture the silicone anode material that will make the battery better. So what have we done so far? Well, a lot of people in the battery space, when they talk about their results, they talk in abstract. They say, our battery is that percentage better than our before and everything else. What we've decided to differentiate ourselves is we've decided to make full-size batteries, okay, and compare them to the best graphite available. Because what our material is, it's a material we can add into it. So we've done, what are these things, which are 18650 size battery. Those are 21700 batteries, okay? What's so unique is by the time we've reached our Gen4 level of silicon anode material, we're reaching, record level efficiency, 7,000 milliampere per amp. But the great news is our material is not just for these batteries. We can put them in battery pouch for drones, in all the types of batteries. So we're developing a material that can be easily mixed with graphite to make a better battery. So if you're a graphite player, you will need to come and work with us to have a better anode material to differentiate yourself, because there's not a lot of differentiation at a certain point in the material, and that's something that's moving forward. The other thing we've developed with Pyrogenesis is fume silica. So fume silica was one of those material that's been developed, dirty process, nothing really new, nothing new in the pipeline. And with Pyrogenesis, we completely rethought about it. We've demonstrated it works at lab scale, and we're now at the pre-commercialization stage. And the hydrogen part is really the third really interesting thing, because the guys at Novasion come from a background where they've always been working and developing autonomous hydrogen. And I think we really reached it to a high level where we developed the METAGENE technology, which is portable hydrogen. It's a versatile hub system. And we're also developing a really unique waste to energy system that's attracting a lot of interest. We've kept that very low key, but in the next 6 months, I think you're going to get a lot of news and people are going to be very surprised with what we've done. So we're well positioned to capitalize on everything we've done so far. We have significant multi-vertical addressable market. Silicon battery material, total addressable market, $15 billion by 2035. And you basically have $22 billion by 2023 for a different market. So it's not just the EV market. We need these type of rechargeable batteries in everything that you do in your life. If you have an electric bike, you probably inside of it there's probably like 50 of those batteries into it, because a battery is a connection of cells. So massive market for what we're doing. Is that what we're doing is when we're making the anode material better. This is where we have a unique position. Fume silica. It's a market where the opportunity of growth are there, but present manufacturing really limits a lot of the things. That's where we move into it. And the global hydrogen market, everybody knows about it. We're attacking a very specific niche where we're presenting a unique solution that's really going to be in demand. Best in class validated technology. Just a few weeks ago, we announced that we had a battery pack drone that delivered 395 watt hour per kilogram, so it puts it in the top bracket of those batteries. And our 21700 cells are basically using regular testing, 6,700, which makes them some of the best available out there. And in the coming weeks, you will see demonstration of what these results represent toward commercialization. Well, we are working on commercialization. Our first Gen 4 battery pack was ordered by a drone manufacturer, and we believe there'll be recurring orders coming out of that. We're working now on building a 2-ton per year continuous anode line manufacturing. And people can say 2 ton per year, that's not a lot, but since we only put 3 grams of the silicone anode material per batteries, that allows us to make a lot of cell with just that 2 tons. And we're working on scaling up rapidly to a 50-ton continuous line in development, which will make us unique, the only non-Chinese manufacturer of silicone material that has demonstrated this ability in batteries. And our first hydrogen prototype will be coming online very, very soon. And we've signed in the fume silica, we've signed an LOI with a major in the fume silica industry, Evonik, which are very happy with our results moving forward. And we've signed an MOU with another player that has a specific application for it. So fume silica is also going to move forward. Government backing. Well, there was a big call in the Canadian government not long ago, last year, about how you can improve the Canadian battery infrastructure. We demonstrated where a silicone anode material were a very unique position. Just to give you an idea, for those that are listening to Canadian politics and listening was going in Canada, just yesterday, the Prime Minister of Canada went to Novasion Graphite to talk about them starting a new mine to make graphite as a strategic material. Now, the logical extension of this will be to start for them to add our silicone into their graphite so they can have a better anode material. So that's what we bring. We bring a technology that's commercial ready, that's drop-in, that can improve the anode materials that are used basically for the end user, the battery manufacturers. So that's really moving forward. So we get government backing, 3 million, and also our hydrogen projects are really open to significant potential European government financing, and that's in the work. Those are the type of situation I can't talk more until the fat lady sings and the government bureaucrats will sign all the documents. But I say it's progressing very, very well. We have a drop-in solution that allows the reshoring of strategic mineral, which is something everybody's looking for. So as I said, silicone-based anode material works very well. Plasma fume silica process is unique. It will allow a decentralization manufacturing of fume silica. And what few people don't understand about fume silica, it's a very light material. So manufacturing plus transportation costs play a big part of it. Autonomous hydrogen on demand, I believe, will be a massive success. The reasons for it just look like a country like Canada, where there's a lot of discussion about moving infrastructure outside of the general area. If you can deliver clean energy that you can use to basically all the mining camps that are there that right now need diesel generator can be replaced by our technology. And what we do is we take recycled aluminum that has no value or minimal value, and we turn it into an energy source. So, and it's autonomous and hydrogen. I'll talk more about this. So another way of looking at our 3 core part, I won't go through it. I think I've already explained it. Silicone batteries, we're working that with Novasion. Massive market potential. Inefficient requires, we really have a proprietary solution. Okay, we're not copying other things. We're developing our own proprietary solution. We're demonstrating it's one of the best out there. The other point also, fume silica, I've explained autonomous hydrogen production. I'll talk more into it, but this is really something where everybody keeps talking about drones. Okay, and although we're drones for batteries, the next generation of drones will require hydrogen for the fuel cells to operate longer. The situation is that they need pressurized hydrogen, and you cannot bring pressurized hydrogen on a combat situation unless you use our technology. So this is going to be opening up massive defense-related contract in those situations. So let's just divide it because every one of these 3 things I'm talking about can be definitely split up into unique companies, split up, because we've done 10 years of R&D and we're reaching that point of maturity where having everything combined in HPQ maybe not be the best way to generate the potential of what we're doing. So the first one is basically cell manufacturing. We're doing engineering silicone anode material. We're doing that with Novasion, which is a company that our partner, we pay for and own the exclusive perpetual license on the technology for North America, and we also own 36.8% of the company. Uh, in a nutshell, don't need to explain it too more. The market for what we're talking, we're just talking about two different markets. 3C batteries for computing, communication, consumer energy, massive markets. We only need to take a small part of it. You can see all the usage where our batteries are going to be needed, where our where batteries are needed, and where our silicon can improve the graphite batteries out there. So we have a definite commercial advantage. So the addressable market are massive. We're not even talking about grid storage application yet. And you can look at the legacy process to make silicon anode material right now. It is very inefficient. Quartz mining, carbothermic reduction, all those type of things. We're finding a way to make it more efficient, more green, and more energy intensive, so we can lower the cost of manufacturing it. Um, so, I'm sort of repeating myself. Existing battery manufacturing line are very costly. We're developing an industrial. We're near term. We have an industrial project. We're initiating commercial production of 18650 and 21700 cell. We'll be focusing more on the 21700 cell because it's really the most efficient battery out there and in demand, and we have a lot of demand for it from different players. So what we have online, we could be able to produce about 1.5 million batteries from now over the next 3 years. And once we jump over with the other plant, then the number is going to go through the roof. They sell between $4.50 to $8 US per cell. HPQ markets that in North America, which include Canada, US, Mexico, under the brand HPQ Enduro. Novasion sells them all over the rest of the world. But remember, we're partially owner of Novasion, so we get reward out of this. And whatever Novasion sales get out of this, it improves the visibility of our batteries in our North American market, which is massive. We've already got initial purchase order from a European drone manufacturer for Gen4 battery material. In North America, in addition to what we have on the license, we've also filed our own proprietary process for making the silicon anode material, in addition to what we're working with Novasion. Yeah, it's this material, that silicon anode material, that led to the Canadian government giving us a grant of $3 million. So what that grant is, for $5 million, we can build a 50-ton per year plant to make silicon anode material at a cheaper price on a continuous process that's not being seen outside of, not even in China, doesn't exist anywhere. And so that's what we're building up. And they financed 33 million, we financed the rest. But it is a great way of doing it because it's government. It demonstrates, it's a validation our technology works. So basically, we're targeting as soon as possible to basically have our 50-ton per year plant working, and that will allow us to make 40 million batteries per year. So you can see it's a small scale up in production capacity of silicon anode. We're going from 2 tons to 50 tons, but the effect on our capacity to generate revenue through the sales of batteries or of cells, I mean, basically goes from 1.5 million to 40 million. So it doesn't take a lot to be a lot of moving forward. These are just some of our results. You can see our progression that we've done. You see 100% graphite. At the beginning, we were mostly focused on 18650, and we realized the market was more interested in 21700, so that's where our focus there. Our Gen4 material is truly a unique high-power material. We exceeded 7,000 milliampere hours, one of the highest out there available. We use a specific demonstration to do this, but that's really opening up new interest for the batteries. I can't divulge too much details, but I think since we announced these results, I think we've signed 10 NDAs from people from institution wanting to test to commercial parties wanting to look into it. So there is growing interest into this material. And as this demonstrates, it is truly a very powerful material. Okay, next, because I gotta go. Okay. So Fume Silica, that's done through our subsidiary called HPQ Silicon Polvere, which is a 50-50 joint venture between us and Pyrogenesis. To understand quickly, what is Fume Silica? Fume Silica is a high-performance industrial powder with exceptional high surface area. and delivers a unique roll thickening agent, anti-caking, and thixotropic modifier. It's used in paint and coating, adhesives, sealant, food manufacturing, and very interesting now in batteries. Okay. Fume silica, substantial competitive advantage over many materials. So it's a very unique material, but its growth and its expansion is very limited by how it's traditionally manufactured. Why we say it's an opportunity, it's a market is going to be 2.6 billion. It's not as big a market as a battery is, but it's a much more focused market with 4 or 5 big players into it because the barriers to entries were so massive. What we're presenting and what we're offering to the market is a way to get rid of completely the barriers to entry, because we go from quartz directly to fume silica, as opposed to the traditional process that goes quartz to silicon metal to silicon tetrachloride to fume silica. All right. So inefficient legacy is basically multi-step, extremely capital intensive. If you want to build a fully integrated vertical line to make fume silica, it's in the $3 to $4 billion to make 10,000 tons per year, which is not at all where we are. We are at least at 1% of that, I think, to do it, to get in those prices. What's interesting about the Canadian market, more of a Canadian perspective, is that there's no domestic production. Okay, so Canada imports all of its fume silica. So it's a 200 million captive market that we have an opportunity to go and attack it as a starting point. And with the LOI we've signed with one of the large, Evonik, because that's public, the largest silicon metal manufacturer, fume silica manufacturer, that gives us a unique opportunity to present this to the market and working with them in tandem to develop this. So that's what on's going in this moment. Wait, let's change to the next one. Okay, yeah. So yeah, the market's big, we have advantage. So what's our disruptive solution? Well, we figured a way to go, bit of a technical thing. We go from quartz, which is a rock like this, and we turned it into a fume silica, which is a long threaded line material that has some specific material. Our competitive advantage is with direct quartz to fume silica. We see massive, gross margin potential compared to traditional. It's an industry that's controlled by large chemical companies because it's part of their integrated process where they take waste from one of their production and move it forward, or they buy waste from another producer and move it on. So they have multiple production risks where we don't have one. We just need quartz to make the fume silica. We use lower energy to do it than the traditional process. We do not use a chemical we do not create a chemical byproduct called hydrogen chloride. And that really simplifies the permitting and the liquidation. And our system is modular. So we can be much closer to the end user, which gives us an advantage. Okay. So really, fume silica, in a nutshell, that's a project where we have an LOI signed with the largest player in the industry. We've met the criteria of demonstrating that we've replicated at pilot scale the results at lab scale, which is the reason why we signed the LOI. And also, in the meantime, we had an end user that had a specific need for the material, approached us about potentially working with them to become their supplier of fume silica. So there's a lot of balls in moving the fume silica at the same time. I'm going to talk more about the hydrogen right now. I may be going fast, so there'll be time for questions. Oh, no, I'm not that fast. I'm slow because you're just appearing. So I'll go through the waste with the METAGENE system. Autonomous green hydrogen. Okay, if you understand, everybody talks about green hydrogen. It's impossible to ship, impossible to transport, very expensive, a lot of infrastructure, a lot of capital intensive system. Our system is very simple. We have a non-hazardous feedstock, which is basically recycled aluminum. But a recycled aluminum of a quality that basically is not good anymore. And we build recharging station where we deliver pressurized material that can be used for drone generator, car refueling, lifeline mobility. In a civilian environment, we can basically pick up the byproduct from a production of the material and make it into new material again. In the military, it's there for camp reinforcement, it's there for drones. Just to get an idea, we're now focusing more on building the container size system. Okay. And what we've discovered is that fundamentally, these systems, when combined with hydrogen fuel cell, We can offer more electrical generation in cold climate. We provide heat for household and industrial application in addition to the hydrogen. And in a hot environment, we basically can support water purification because our system does not need portable water. We can use regular water, seawater, stale water, or even urine. That's usually a requirement of the military when we're design system. Last one, but quickly, basically, the other one is our breakthrough. There is a final waste in the aluminum recycling that's basically called bad aluminum dross, which is a toxic byproduct, which is very expensive to, anyway, in Europe and in advanced countries, basically to landfill. There is always recoverable aluminum into it, but all the processes to do it are very expensive. We discovered a very cheap process to do it. And I would say in the coming 6 months, you will hear more about this. We've been very sort of discreet about this. So in a nutshell, corporate information, this is how we are. HPQ Energy is the name of the subsidiary in North America to sell our battery material and our hydrogen. Fume material is another thing. I didn't talk too much about it, but we own patent to make fume aluminum and fume titanium. Our interest in Novasion and HPQ Silica Polvere for fume silica. Anyway, as I said, the rest is just the management industry. So since you appeared, Lindsay, I sort of figured that my time was up for questions.
Perfect. Absolutely perfect. I love hearing about the company and learning something new about, the silicone sector as well. I think that we're all needing a little bit more information about all that. So thank you for joining us today. Now, I have a couple questions here. Bernard, HPQ has spent years developing multiple technologies simultaneously, which is not the easy road for a public company. I mean, if you look back from now, what was the hardest period where you had to keep moving forward, even when the market probably didn't yet understand the scale of what your team was building?
It's always been like this because we were financing advanced R&D with retail investor, which makes it very, very difficult. And it was hard until we got a clear vision. One of the reasons why we have so many different volatility is I always wanted to de-risk the project. Okay. But when you do R&D, you don't control the timing. And unfortunately, or fortunately for people that are looking at HPQ now, all the timings we've done, originally the idea was to have one project succeeding, moving on to the next one, moving on to the other one. Because the fume silica took longer than we expected, but the battery was faster. And the hydrogen was in between, but it's now coming into fruition. We now find ourselves at a junction where we have commercial batteries that are ready to be sold. We have interest from players coming into it. We have developed our silicone anode material can be plug and play for everybody. So there's a massive market. We are being approached by graphite manufacturers that would like to advertise that they have a better anode material with our silicone into it. At the same time, we're being approached by end users that would love our batteries that give up more performance to improve their system. So all of this is coming online at the same time as we have the fume silica. Luckily for HPQ, the way we've done it so we don't build a massive infrastructure, we've always partnered out our R&D. So fume silica is done by Pyrogenesis, the technical part of it. We're now entering the commercial discussion about building the first plants. And this is where it's going. So that's advancing in one step. And the autonomous hydrogen was a very specific demand that was originally given to us by a NATO-based military. Okay. And it has evolved, There was many, how can I say, it's without being a direct iteration of many systems, there's other systems that went into it. But we think now that with this solid piece of aluminum that we can use as an energy cell, we really do have a killer option that's going to come into it because it meets all the check mark everybody needs. And then at the same time, you look at Canada, which is calling about building a lot of military defense infrastructure in the north. Well, there is no energy infrastructure. Okay. Imagine there's a lot of First Nation cities where they have a hard time having portable water and energy. Well, we offer a solution where we take waste aluminum. We convert that into hydrogen, which allows us to purify the water so you can have fresh water to drink. At the same time, one of our systems, which is a container side system, can basically give the heat and the energy for 10 to 20 houses. Yeah. So this is what's coming along, and in the next 6 months to a year, you'll see into it. So a lot of the work HPQ has done in his R&D. We've talked a lot about a few of our R&D projects, and the other one we've kept more quiet. But we've now reached a point where we have four of those. We're only talking about three that are going to come in fruition. That each one of them should be an independent company. Well, I see you're
Fair
lifting your
enough.
hand.
Yeah, no, you have a lot. You have a lot of products there. They all sound really great. I really do appreciate the fact that you took a real life situation and you really broke that down to simplify just how impactful your product is. I want to
Hmm.
flip over and ask a quick question about your Gen 4.
Hmm.
Now, you recently, your Gen 4 battery results have been extremely strong. So,
Hmm.
what are strategic partners or potential customers telling you privately that investors may not fully appreciate yet about that commercial potential of this technology?
Well, we've signed multiple. We've signed multiple NDAs. We don't advertise this anymore. There
Fair
is
enough.
strong demand for the material. There's the big interest. Now it's really for us going to be how do we scale up the production for the demand. And I think that's what I'm trying to find the right startup clients where we'll be using our level of batteries. If you think about it, even 40 million batteries is not a lot of cells. Is not a lot of in the overall demand. The concept for us is demonstrate it works, find the right partners that are willing to come into it, and we are having those multiple discussions. I think our partner Novasion that was in China has reached one of those preliminary targets showing interest. So it's coming online. It's just we kept improving the battery. We have a better battery now. We have a better way of making it, cheaper way of making it, and we're now scaling it up. So I think that's the point that people don't understand is great results maybe not translate instantaneously in sell, but look, we've already sold some for a drone manufacturer.
Right.
There's a lot of discussion on those regards. There'll be follow-up sales. There'll be follow-up issues.
Well, I'm excited to hear what comes down the pipeline next. I know that we're out of time here, so we'll wrap this up for you. Bernard, thank you so much, so much. We're going to be watching out and definitely keep this one on the radar for sure. Where can we find you for those people that are just listening to the audio?
You can find us on the website, hpqsilicon.com.
Perfect. Perfect. Well, thank you again, Bernard. It's been a pleasure, and we'll talk to you soon.
Thank you.